everybody, it's Franco, and today I am going to power up these ClearPath drives and get into the auto tuning procedure that Teknic specifies for these things. So let's go ahead and put some power to these drives and get started. In here we have the electrical enclosure that you have seen a few times now on the past few videos. We have, let's start from the beginning here. So this is the cable that feeds 110 volt power into the power supply for the drives. It's connected up here where all my other 110 volt power sources are wired up. This is the DC output connection from the drive. So the power supply itself has two connections on it. So it has two ports. So technically you could plug two ClearPath servos directly into this IPC5 and it's plug and play. Obviously I have a router, so I have more than two motors. I have four motors. So what I've done is I have taken one of their cables and I've trimmed it down, and what I've done is I've wired it up to these two terminal blocks. So I have all my negative voltage here, all my positive voltage there, and you can see, basically I have four motors, wired up, connected to this power supply. This is a simple way to do it, but ClearPath folks actually have maybe a more elegant solution. So rather than doing what I did, you could also buy this little guy that they provide, and it's called a Power 4 hub. So what you do is you supply it with the power from the power supply, and then you plug your four motors into this, and that power supply can power those four motors. Now it's more than just a breakout board or whatever you want to call it. It actually does some other functions too. So in addition to giving it the power to run the motors, you can actually supply 24 volt power to this thing. And what this will do is, let's just say you fire off an e-stop and you disable your drives. What this board will do is it maintains the position. So when you reset your motor and power it back up, it will still know where it is. And because I don't have this wired up, because I've done it kind of the old school way, I'm assuming that whenever I disable my motors, I'm going to have to home the machine out again to find its home position. Where had I used this and wire this up, plug this thing in, it would have made it a little smarter, a little bit more elegant. So why did I not use this? Why did I choose not to do this? Well, there were a couple of reasons. I don't really have any good reasons, I'm going to be honest with you. One reason is I was kind of running out of room in this enclosure. It's just getting a little harder to shoehorn things in there. And the other reason was, I'm going to come totally clean on this, as I was fishing all the wires through, I had to cut the ends off of these things, right? So remember, all of the ClearPath products come with these nice Molex connectors wired up, right? Everything can be plug and play. I had to snip those off, and I discarded those stupidly, and I don't have them anymore. And yeah, so that was my big mistake. So it was my own dumb, stupid fault. I don't have the ends to the cables, and I just didn't have time to order more of them. So I chose not to use the Power Hub 4. But if you're building yourself a real nice, serious system, definitely consider the Power 4 hub, and it'll make your machine even more awesome. And yeah, I ran out a little bit of room. I probably could have found a way to put this thing in here somewhere. I guess it would have fit right there. But so anyway, Power 4 hub. If you want to go the extra mile, use one of these. If you don't, you can do what I did. So I am going to power this thing up. So let's pause the video and get back into it. Power has been connected, and I've double checked all my connections. I feel pretty good, so here we go. Let's power this thing up, and I'm going to try to keep the camera on one of these motors. So be warned, these motors come from the factory with a no-load tune in them. I don't really know what they're going to do when I power them up. They may jerk and twitch, I'm not sure. So let's see what happens. Oh yeah, something jerked, something twitched, but I don't see any smoke. And I believe that is a good sign, the green light that's flashing. And let's see. So there is the Z-axis motor. It's solid light. Guess that means it's happy. Happy. I believe that's happy. Great. So all the servos are powered up. Okay. So right now they should be freewheeling, and they are. They are not holding a position yet. They are totally freewheeling, and that is as it should be. So next step is to tune. So my first comment about that is the tuning algorithm is actually really intelligent, right? So this tuning algorithm is going to do all kinds of cool stuff when we run it. It's basically, trying to tune out the resonance, I'm assuming, right? It's trying to optimize performance, get rid of the vibrations, the resonance. The ClearPath people told me that the helical beam style couplings that this router kit came with are not the best type in the world for a servo, because what happens is they're basically kind of like a spring, and they generate some resonance. So they recommended that I buy some different type of couplings, and I'll be honest with you, I actually forgot to do that. I totally forgot that I had to order those. So their recommendation, if I chose to use these cheap ones, was to wrap them in electrical tape just to try to take some of the resonance out of them. So it was nice of the Teknic people to tell me that. So I did it, and I'm going to give it a shot. And really simple, I'm going to do the Z-axis first, and all I'm going to do is pop this little cover off and plug into the motor and run their software. So on to the next step. Trained here on the Z-axis. I'll show you how this works. And I am screen capturing so you can see the software. Software is available on the Teknic website. If you go to downloads, you can choose software for the ClearPath. And it's this option right here, motor setup. I have the program running. This is what it looks like while it's running. They give you a program, well, you have to purchase it. It's not very expensive. A programming cable, which is basically just a USB cable. And what I'm going to do is plug that cable in to the back of the servo motor. There it is. And the software is detecting it. And what it's doing is it pops up, and it knows that I've already tuned this motor, so it's giving me this radio button here. I have already tuned. Well, let's just pretend that I didn't. So I'm going to pick auto tune. Then I'll press next. It's giving me a warning message. Make sure you read this warning message. It's telling you how powerful the motors are, how fast they move. You can hurt yourself, you can break things. So read the message. Be very careful. Don't hurt yourself or break anything. And then click next. Now it's asking you if you want to use all of the torque. So this motor is capable of producing 198 ounce-inches of torque. I'm going to use 100% of that torque. If for some reason you want to use less than the max torque, you can dial it back to 50%, whatever, but I'm going to use 100%. Tuning stimuli. So it gives you the recommended dynamic. It's a more aggressive tuning mode. It's going to, make more aggressive moves. If for some reason you can't handle that, you can slide this back, but just remember, softer tuning results may not be ideal. So I'm going to leave it at its max setting. All right, so just before the end of the tuning process, the auto tuner will make some relatively fast moves. The mechanical system has speed limitations. You can enter a max motor velocity. You'll get best results by using a velocity as close as possible to the default setting. So the default setting is 1030 RPM. So on this WorkBee router, if we, let's do some math here. Let's get the calculator up. So let's just say, okay. So we have the pitch on our screws on this kit is 8 millimeter. So if we do, 1 inch is 25.4 millimeters. So 25.4 divided by 8 equals 3.175. So it's going to take 3.175 revolutions to make 1 inch. So now if we take 1030, so if we say, let's put that in memory. So if we say 1030 divided by 3.175, that means that when we use the max RPM of the Teknic ClearPath Servo, we're going to be moving 324 inches a minute, which is pretty fast. I'm going to leave it at that setting. But if for some reason you don't want to go that fast, you can dial this back. Okay, this is an important one. On a milling machine, a lathe, a router, you want to pick a limited rotation because you have hard stops. You can't rotate forever. If you were on some kind of machine like a rotary indexer or something that could spin indefinitely, you would pick unlimited, but we want limited rotation. Now it's asking you to show ClearPath software the full range of motion that the axis can move through. You can jog this by hand, you can move it electronically under power. I'm going to do it by hand. And then I'm going to click next. Now it's telling me to move through my limits of travel. I'm going to take the dust shoe skirt off of here for a second so I can see where the tip of the tool is. And I am literally just going to jog the machine all the way as far down as I think I can safely go. And then I'm going to go back the other way. And I'm just going to go until I almost touch the homing switch. So I won't completely touch it, but I'm going to get pretty close. Something like that. And just for good measure, I'm going to put the dust shoe skirt back on. Okay, the software is happy. I have enough travel to do a good tune. Press next. It's asking me to confirm all my settings. I confirm, next. And now it's telling me that this thing is going to make weird noises. It's going to hum, it's going to vibrate, it's going to jerk around. It might take a half hour depending on the mechanical system. It's definitely going to take several minutes for sure. You can press escape to stop, or you can click a button on the screen to stop or pause. So let's go next. So when I click run, it's going to begin the process. And Now it will start to move and jerk and jump around. Winston came out to visit me. So I'm not going to stand here and record this whole process because it takes quite a while. But basically you're going to see this thing moving and jerking and humming and vibrating and doing all kinds of crazy stuff. So I think what I'm going to do is just pause all this while it's running, and I'll pick it back up at the end and show you what to do next. And well, before I go, you can see it's jumping around, it's clicking, it's doing some weird stuff, but that's normal. That's what it's supposed to do. Okay, so we're close to the end of the process now, and what happens is it starts out really slow, and the more it progresses, the more rapidly it moves through its routine. So we have hit 100%. It is time to move on. Next. Now it's just asking me, it must be disabled. Okay, so we have to disable it. So if you have a really heavy axis, you might want to like jog the axis, lower it so it doesn't drop when you lose power. And that's what this is for. So you can use these buttons to actually move the router or move the axis. So I'm very carefully, I think I went clockwise. Let me just, nope, I went counterclockwise. So let's go. I'm just going to move it right about there. That's good. Going to press disable. Next. Fine tuning. When running, ClearPath may be manually fine tuned. Moderate amount to suit your preference. To dial out noise versus stiffness. It says open the fine tuning dialog under the setup tuning menu if you want to make fine tuning adjustments. Motor identity. You can change the motor identity settings at any time by opening the motor ID. Okay, I'm going to pretend like I want to do it right now. Basically, I want to name this motor. So I will click finish. This pops up. Now I've already typed this in, so let's just type something else in and make it a little different. There we go. That is the name for this configuration. Press OK. And OK. So now we're at the next part of the screen. And you can navigate through here. You can, you have your typical options that you would expect would be under File, Edit, Cut, Copy, Paste, Motor ID. That's what we typed in. Zero position, set RMS peak. I'm not going to mess with those. Mode, we want step and direction. Setup, tuning, that's where you can find that fine tuning. Advanced, I'm not going to mess with any of that right now. Help, lots of nice information under help. So let's go here to input resolution. So I have the enhanced version of these motors. I want to set it to 6,400. That's very important. That is the resolution of the encoder, I guess, or whatever. This is the number of steps or pulses per rev, I guess you could say, that this enhanced motor is capable of. 6,400 pulses per revolution, which is quite a bit. And that's what I want to set this to. step and direction, right? Because we're using the centroid acorn, we want to do step and direction input format. Torque limit, this is the same thing that we had before. I want to use 100% of the torque. I'm not going to change that. Okay, homing, we're not going to do homing right now. That's for future stuff. We'll work through that later. Right now, I'm going to disable homing. Profile conversion, the RAS setting. Right now it's set to 16 microseconds or milliseconds, I guess. I don't know. I guess, well, I think it's milliseconds. So there's some general guidelines here. So for a wood router, they recommend anywhere between 16 and 24. And they tell you to start with the lowest setting first. So I'm going to leave it at 16. If that doesn't work, I can increase the setting, but basically you want to start with the lowest setting. So what that is this is something that's applied to each command, right? So if you set it too high, it'll basically be changing the way your machine tool is moving. So you want to set this as low as possible, but only increase it if you feel you need to improve the smoothness of your motion. So as you increase the RAS settings, your motion will become smoother because the RAS is reducing the amount of jerk in the command. The RAS time will be added to your move. So that's why you don't want to have too much, right? But they do recommend using some of it. So I'm going to leave it at 16. That's what they recommend for a wood router, to start at 16. And I would imagine probably for a typical DIY, milling machine or lathe, probably in that same range, 16 to 24. So that's what that is. So 16. And okay, the rest of the stuff is basically if you want to manually test your servos. So you can override the inputs, you can enable it, and then you can jog. And these are the settings: acceleration, velocity. So jog clockwise goes up, jog counterclockwise goes down. Just be careful, there's acceleration and deceleration, so don't get too close to anything or you may bump into it. So the motor's working. And the final thing I'm going to do is come up here to File. I'm going to save this configuration. And I've already done this once, but I'm going to override it right now. I'm going to save this as the Z-axis configuration. So I would press Save. And I want to replace the one that's in there, yes. There we go. So we have auto-tuned that Z-axis motor, and we've saved the configuration. Let's move on to the X-axis. Let's do that one next. All right, back to the X-axis. Same thing. I got my Z-axis is jogged up into a safe position where I can move the machine and not run into anything. I am going to plug into the X-axis motor. It recognizes it. And it knows that I've never tuned it, so it's asking me to auto-tune the motor. That's what I want to do. Next. It's giving me the warning message. I understand what I'm doing is dangerous. I needed safety first, all that good stuff. Next. Full torque, dynamic, yes. I'm going to go for it. I'm going for the full max velocity. Limited rotation. And for this one, I'm going to use power to move the mechanics. Next. And what this is telling me is when I hit the control button, it enables the drive. I let go of it, it disables the drive. I can control the speed at which I move it. And so I'm going to eyeball this. Hopefully I can do this without making any mistakes. Okay, I'm going to go the other way. Bring it. That looks good right there. Now we'll go back to the other end of the axis. Actually, I'm going to turn the speed up a little bit. Slow it back down. Oops, other way. And that looks pretty good right there. All right, and I'm going to let go, let the axis go back to unpowered state. Press next. Have plenty of, all my settings are good, it's confirming everything is good, it's happy. Press next, it's giving me the warning, it's going to make noises, it's going to jump around. It may take a while, okay. And now when I press run, things ought to start happening. And I can see the servo motor is twitching. So just same as before, I'm not going to sit here and watch this whole thing run. I will pause the video here in a moment, and then we'll pick this back up once we get closer to the end. Okay, so I'm going to record a little bit of this just so you can see what it's doing. It's at 15% right now, and yeah, it's twitching and humming. Mostly all over in this region. Hasn't made any really big moves yet, but we will keep an eye on it. Yeah, okay, so starting to get some very interesting movements here at around 27%. Startling, I would even say, but this is all part of the process. So we are up to 74%, and this thing has walked all the way across this axis. I guess it's starting to figure itself out, and hopefully this little slider will start to progress a little more rapidly. This does take several minutes, so plan for that. Wow, Okay, so that took a while. Next, and it's asking me if I want to jog it to someplace, and I'm going to try to do that, just to get it to the close to the middle of its travel, something like that. That is good enough. I'm going to disable it. Click next. We know all about the fine tuning. Yeah, I want to rename the motor. Finish. I'm going to call this X axis. Okay. And the same thing here. Now we have to configure it. So we want to pick 6,400. Step and direction. Leave it at 100% of torque. I'm going to leave this at 16 milliseconds. Disable the homing. And we can manually test. Moves. That's all good stuff. Just punch in a higher number. Great, I love it. Okay. Then we're going to do a file save configuration. We'll call this the X-axis motor. Save. Great, X-axis is done. So we've done Z, we've done X. Now the challenge is Y. So Y is a little different on this router because it's a double gantry machine. So there are two Y-axis motors that have to move simultaneously to move the machine. So you cannot run the auto-tune routine on one axis without moving the other. You'll break the machine. It's physically not possible. So how do you get the double Y-axis motors tuned? Well, there's a little procedure for that, and I may save that for the next video just for the sake of time. Basically what we're going to do is we're going to use the X-axis. So what I'll do is, so each individual Y-axis technically has less work to do than the X-axis, right? So the X-axis is moving all this weight when it's running. The Y-axis, each, because there's two of them, technically they individually don't run as much weight. So what I'll do is I'm going to take some of the weight off of the X-axis. So what I'll do is I'll remove the router. And then I'm going to run the auto-tune on the X-axis again, but I'm going to save that as Y-axis. And I have two Y-axis. So I'll save it as Y-axis 1, and I'll save it again as Y-axis 2. So I'll use the X-axis without the weight of the router on it to kind of simulate each of the Y-axes, and then I'll load that into each Y-axis and go from there. So that's how I'm going to get the tune for each individual Y-axis. Alright, this video is long enough. Thanks for watching. Have a great day, and I'll see you soon.